That should do it. Okay. All right, so let's go ahead and start the unit circle, okay? Because I do feel that like each one of these, we did have an example with it, and that's gonna kind of be the process. Maybe at the end, if there's one we can go over, that's fine. I know someone mentioned 12. Take a look at 12 real quick. It's just an easy one to talk about. 12 is a nice polynomial. X squared, x, the number by itself. So there's no problems with it. Any number you give me, any decimal, any fraction, any positive number, any negative number is okay. And so that's what 12 is saying. From negative infinity to positive infinity, that's good. Okay, so always take advantage of those polynomials. Okay, they're all good. All numbers are good. And remember, fractions is just whatever makes the bottom 0 gets tossed out. And for radicals, it has to be 0 or positive. All right, let's take a look at this unit circle. Now remember, we're going to try to get a lot of trig in one day. So let's just see how far we can get. It's just, trig comes up here and there. We're going to use it in a different type. We're going to use it for derivatives. So, you know, it's going to be a little bit different situation that we're going to talk about it, but it's kind of nice to know what trig is, right, before you use it in a different situation. All right, so this is basic unit circle. Why is it called unit circle? Why is it called unit? What does unit mean? Good trick, and no one's taught you why it's a unit circle. Unit means 1. The radius on the circle is 1. And that's fairly important. All right, so let's draw. You guys don't have to. So you could kind of go back and forth with notes, or if you just want your circle out, that's okay. What a good way to do with that overhead. All right, so we mark off certain degrees we like a lot. Okay, they're just easy to work with. They come up a lot. So that first one is 30 degrees. So is there a line somewhere on there? Put it in one of the lines. Oh, I think there's a little degree symbol there, right? Okay, so on one of the lines, 30 degrees. Now we mark it somewhere out here, right? 30 degrees. What are we really labeling though? What is actually 30 degrees? This angle, right? This angle is 30 degrees. It's just that we're going to have a whole bunch of angles, and so it gets messy in the center. But understand that this 30 is talking about this angle here. All right? Skip the middle one, and then the next one is 60. Okay, again, do we understand here? We can even start to see the lines, but this is the 60 degrees. Do you understand that that's the 60 degrees? Right, and then this one is how much? This one is 90. Okay, we just count by 30s. Okay. We're not going to use this a whole lot, the degrees, but it's a good place to start. All right, after 90 comes counting by 30, so then comes 120. Skip the middle one, and then comes 150, and then halfway around the circle, we're at 180. Again, and that's maybe good to see too. We're actually talking about this angle here. It's just easier to identify it at what's called the terminal ray, where the angle stops. All right, let's keep going. What do we got? And 30, so that takes us to what? 10, skip the middle one, and 30 takes us to 240, and then we're down at the bottom, 27. Keep going at 30, so we're at 300. Skip the middle one, 330. And then where are we all the way around? We could actually be at 0, or we could be at 360. Okay, either one you can mark. A lot of times we actually mark at 0. Because we always like to keep the number smaller, so it's better to mark 0 than 360. So we get the idea. Okay, what's the next line for? Instead of degrees, what do we measure angles in now? What do we call that other unit? Radians. Yes. So radians deal with pi. So do we know? Here we counted by, oh wait, no, what else do we have to label? We still have to label those missing ones. Those are what? These lines, right? I didn't label every line yet. What are these? These are 45. So 45 degrees. Then you do have to hit this one 90, so it's kind of a redo. Another 45 takes you to 135. And then another 45 takes you to 180. Where's our next one? Okay, so what's our next one here? Are we okay? You guys tell me, what's our next one? 225. What is it? 225. 225? Yes. And then we add 45. That takes us to 270. What's our next one? Add another 45. Are we okay? And okay. So 315, and then another 45 would take us to 360. Now, on this unit circle, is there an angle 20 degrees? I mean, yes, 20 degrees exists, and yes, we can talk about it in terms of trig. It just doesn't come up a lot. We don't use it as our reference. So these angle measures, these are kind of like our reference, so to speak. These are the ones that we use a lot. Okay. The other ones are on there. They're just not as nice numbers to work with, and they don't come up as often. Okay. But don't think that these are the only ones out there. Okay. Any angle measure that you can think of, that's it. Okay, so this is 0 radians. How do we, what's 30 degrees is the same as, anyone know? You count by 1/6, but you put a pi with it. So this is 1/6, but it's pi over 6. Skip the 45. This is 2/6, put a pi with it, but that can reduce. So that reduces to pi over 3. Okay, so 1/6, 2/6, 3/6, but that reduces down to 1/2 of pi over 2. How are we doing? Okay. So just count sixes: 1/6, 2/6, 3/6, 4/6, but that reduces. 5/6, that's kind of nice, that doesn't reduce. And 6 over 6 is pi. 1, and then we put the pi with it. Okay, 6 over 6, then this one is 7/6. 8/6, but it reduces. The next one is, can I see? Okay. All right, the next one is 9/6, but that reduces, right? 3 goes into it, so 2 pi over 3. All right, where were we? 9/6, so this is 10/6. 2 goes into it, so 5 pi over 3. Where were we at? 10/6, 11/6, so that doesn't reduce. And 12/6 takes us to 2 pi, all the way around the circle. So 0 is okay, or just it's also a good reference, 2 pi. Just like 360 and 0 go together, 0 and 2 pi go. All right, so for the 30s, you got to count by 6s. 1, 6, 2, 6, 3, 6, try to reduce. Does anyone know what we count the 45s by? 45 is the same as, or should we slow down? How are we doing? Okay. All right, 45 we count by 1/4. So 45, this is pi over 4, 1/4. You hit the 90 again, 2/4, but that reduces. 3/4. It's the ones on the axes. So this is 3/4, so this is 4/4. All right, what's the next one? This one is what? That's a nice one, doesn't even reduce. It is 5 pi over 4. 6 pi over, if you want to hit the one going down, 6 pi over 4. But that, yeah, this should be. I don't know what I said. This should be. Yeah, hang on, we gotta change that. Did I say that or no? I don't know. I might not. That should be 3 pi over 2. Yeah, that looks better, right? Because, and that's actually kind of a good check because this was 1, 2, 3, 4, 5. Okay, yeah, 5 pi over 4. 6 pi over 4. That looks better. Yeah. Okay. 6 pi over 4. So make sure you change that one. This then is 7 pi over 4. And then this one is your 8 pi over 4. Now, the goal is, and we still got more to fill out. The goal is that you do this without looking at the unit circle. So we'll kind of talk about that, but first we need a picture so that we know what we're doing, especially if we try to do it without the unit circle. Okay, now what do we still need? We need sine and cosine. We need x and y. We need coordinates. Right? What are the coordinates of this point here? So now remember, this 30 correlates with this angle. So let's look at this triangle. 30. We'll draw in this triangle. So I'm going over 30, or I'm sorry, this is 30 degrees, and then I'm going over till it forms a right angle. And then that's 95. So 30, this is a right angle, and then this has to be 60. Do we know across from the 30 is 1? Across from the 60 is square root of 3. And across from the 90 is 2. Now, we've got a little bit of a problem because this line is this line. And what is that line in terms of the circle? What is that line in terms of the circle? That line is the radius. Yes. And what do we just said it's a unit circle, so our radius is supposed to be 1, and we have it nicely labeled 2. So what we do is we divide this by 2. But then we have to divide them all by 2. So now we have this triangle, 30, 90, 60. This is now 1. This is now the square root of 3 over 2. And this is 1/2. So now I go over, this is my origin. I go over this distance. This distance is how much? This is my origin, square root of 3 over 2. And I go up how much? This right here is this right here, which is 1/2. So the coordinates here are the square root of 3 over 2. And so then when it's 60, we can just flip this around. This side is now the 1/2, and this side is the square root of 3 over 2. So now here it is 1/2 square root of 3 over 2. That goes with pi over 3. We could just rearrange this. We can put the 60 here, the 90 here, and the 30 here. Okay, across from the 60 is the square root of 3 over 2. No, I'm sorry, hang on. Across from the 60. Okay. Across from the 60 is the square root of 3 over 2. Across from the 30 is the 1/2. And then across from the 90 is 12. So now we have 1/2 square root of 3 over 2. And that fits. We could draw it in without too much here, but this would be the 1/2, and this would be the square root of 3. Okay, now this triangle, this 120, you don't really have a triangle that fits this 120, but it's actually fitting. Let's see if we can draw one more picture. It's actually fitting this triangle. It's actually fitting this triangle, which correlates to this one. So that is negative 1/2 positive square root of 3 over 2. So how come it is, so for 120, it is negative 1/2, but then positive square root of 3 over 2. How come it's negative? Because what do we also have to do? We're putting the circle on an XY coordinate plane, right? So we're also talking about, and that's why we're writing these points, so that's why it's negative, and then there's only a few numbers here, guys, and we'll talk about this a couple times. The longer line is the square root of 3 over 2. The shorter line is 1/2. Okay, so I know a lot of people kind of look at this and they do like this triangle with this triangle, this triangle with this triangle, and that's good. But if you're just trying to do it on your own, if I just give you randomly 5 pi over 6, I mark it on my circle in general where it's at, and then I go long line, short line. Long line, short line. What does the long line have to be? Square root of 3 over 2. That's the bigger number. The short line has to be 1/2. So my longer line, my x, and I'm going to the left, so it's negative. Negative square root of 3 over 2, and then up 1/2. Long line, short line. Long has to be square root of 3 over 2. Short has to be 1/2. And that's how you do it so that you don't have to draw your entire unit circle. You don't even have to know what triangle or it matches. When I go down here to 210, long line, short line. Long line, short line. So 210 has to be long line, negative square root of 3 over 2. Short line, negative 1/2. Now, do we see why it's negative? Because we're in quadrant 3, and so x's are negative, y's are negative. All right, how about, maybe I'll put it in here. 4 pi over 3, short line, long line. Short line, long line. So short line, this has to be negative 1/2. Long line, negative square root of 3 over 2. So just do short line, long line. Short line, long line. All right, if I'm going to 300, short line, long line. Short line, long line. So short line is 1/2. I'm coming to the right. Long line, but it's going down, so square root of 3. And then to 330, long, short. Long, short. So long has to be square root of 3 over 2. Short has to be 1/2, but I'm going down, so it's negative. This is just to help us reduce. This is questions on that. Long line, short line. Try to figure out where your location is. So I still have to think about where 11 pi over 6 is. And then I have to think about long line, short line. All right, how about, well, let's even do this one. On an XY coordinate plane, and I came out directly to the right, what is the coordinate of that point? I went out the radius. So I went over to the right 1, and then up or down nothing. So this is 1, 0. How about this one? Where did I go? 0, and then up 1. 0. How about at pi? Who wants to give me pi? Yep, so we went to the left, so she said, okay, it's got to be -1. And then I didn't go up or down, I literally went to the left. So 0. All right, how about 3 pi over 2? Make sure you change that one, 3 pi over 2, right? Was that the one? 3 pi over 2 is 0, and then -1. Okay, we're getting there. All right, so what's our last, did we do them all? Except the 45, right, or the pi over 4s. All right, so let's take a look. Oh, let's look at this real quick. If I said, let me read it. If I said I want sine of 30 degrees, this goes back to SOHCAHTOA, right? So sine is opposite over hypotenuse. So sine is opposite over hypotenuse. So that would be 1/2. Opposite, are we okay with that? Opposite over hypotenuse. Now, what happens, I'm going to do the same thing on this. Once I did divide by 2, look at this one, sine of 30 degrees. Opposite is 1/2, but hypotenuse is 1. So 1/2 technically over 1, which still takes us to 1/2. We like it like this better because now we don't have to do opposite over hypotenuse. We know that this y value is sine. The y value is always going to be sine. We're still doing SOHCAHTOA, but we're always putting it over 1. And so we don't need that bottom value anymore. That's the nice thing about the unit circle. We kind of forced this to already be opposite over hypotenuse. So sine goes with y. Sine of theta goes with y. And what does cosine go with? Cosine goes with x. So I've already forced this to be adjacent over hypotenuse. It's not like that's a totally different thing. It's this is adjacent, and my hypotenuse is technically over 1, so I don't care about it anymore. So we're still doing SOHCAHTOA. It all goes back to SOHCAHTOA. But we force that hypotenuse to be 1, and so now this is cosine. Notice I have to put this. What does this mean? Sine of theta. I have to tell you, theta is just a Greek letter, and we always use it for an angle measure. So I have to tell you the angle measure. I have to tell you I want sine of 30 degrees, or I want sine of pi over 6. I have to tell you what angle measure we're talking about. Then you go find the y. For sine and for, which one did I put? Did I put, was I doing sine? Sine, then you go find the y. Cosine, then you go find the x. But I have to tell you the angle measure. Sine by itself, that doesn't mean anything. You have to do sine of an angle. This is saying give me the y value, but I have to tell you where. The y value here at pi over 6, or the y value here at pi over 3. All right. What do we still have to do? Let's do the 45. You cannot go wrong with the 45. That's It even shows you more why we like 45s. It's an isosceles triangle. 45, 45, 90. 1 and 1, those two have to be the same. And then the square root of 2. Great that we have 1s, but they're in the wrong place. Where is the 1 supposed to be? Got to be the hypotenuse. It has to be the hypotenuse. So we're going to divide this by the square root of 2. Divide them all. 45, 45, 90. Now we've got 1. We usually don't write it like this, 1 over the square root of 2. What do we usually do with that? Rationalize the denominator, right? We get rid of the radical in the bottom, moves to the top. So we usually talk about it as square root of 2 over 2. And then same thing here, we can rationalize square root of 2. Same thing, all right? Sine is still opposite over hypotenuse, but because it's a 1 now, we don't have to worry about it. So 45s are great. If I give you a 45 or pi over 4, we label those 3 pi over 4, your answer has to be square root of 2 over 2. Okay? They're both, x and y are the same, cosine and sine are the same. You just got to get your positives and negatives right. So this is square root of 2 over 2, square root of 2 over 2. What is this one? Who wants to try 3 pi over 4? What's 3 pi over 4? That's a 45. So it's got to be square root of 2 over 2, square root of 2 over 2. You just got to do negative and then positive. So negative square root of 2 over 2 and then positive. There, you don't even have to do long short. You just have to recognize that you're at a 45. Okay. There. This one here, I think we can stick it in here. It's a 45, 5 pi over 4. So negative square root of 2 over 2, negative square root of 2 over 2. And then my last one, 315, positive, so square root of 2 over 2, and then going down, negative square root. The nice thing about those points is we've already taken into consideration opposite over hypotenuse. So sine and cosine are pretty easy or easier to do. Sine is y, cosine is x. Okay, so make sure you write this down. You definitely want this. How about let's finish the rest. What's tangent? And it comes from opposite over adjacent. Tangent is, if you do opposite over adjacent, it is y over x. Does anyone know the reciprocal of sine? These don't come up. It's kind of this order. Sine and cosine are definitely what we're going to see the most. We'll see tangent a little. We'll see the rest even less. But does anyone know what the reciprocal of sine is? The letters don't go together. So sine goes with cosecant. So if they're reciprocals, cosecant is 1 over y. Cosine goes with secant. So they're reciprocal, so secant is 1 over x. And then tangent goes with cotangent. And so if they're reciprocals, cotangent is x over y. And again, that all goes back to SOHCAHTOA, but making it that hypotenuse of 1, we can condense it down to this. Okay, so how are we doing? Okay, we're not sure. We're giving up. Okay, so let's, I'm going to erase this. You can use your unit circle, but we'll also try to talk about just doing it like drawing like what I call a picture, and I'll show you what I mean by a picture. But let's see if we can answer some. Oh, that's good work, and I'm going to erase. It looks impressive, if nothing else, right? Okay, here we go, guys. what can we still, oh, I questioned it. What do we still have? There's one more piece of trig that we're not really going to get to, but what is that piece? We heard of the sine wave and the cosine wave. That's taking the angle measure and graphing all the x values. If I graph angle measure x value, angle measure x value, angle measure x value, I get the cosine wave. If I plot angle measure y value, angle measure, maybe I should say y coordinate, if I graph all these y values, that is the sine wave. That's where those waves come from. So the waves come from this, which comes from SOHCAHTOA as well. Okay, it's just plotting angle measure and x values, or x coordinate, I'll say. That creates the cosine wave. Angle measure y coordinate, that creates the sine wave. And that's where all that stuff comes from. Someone who has a calculator. Do cosine of 30 degrees. Have a calculator. Let's take a look at it, because that's going to kind of be our homework. Cosine of 30 degrees. Now we're going to go to radians, but for right now it might be easier just to do it in degrees. So I may be in radians. So what is that? You tell me. Does anyone remember what is that in radians? What is 30 degrees in radians? You remember it's called, you can look at your unit circle if you want. The 30 is pi over 6. Pi over 6. So my calculator is telling me 0.866. Where is that coming from? Well, cosine of 30 degrees is cosine of pi over 6. So this is what I would do if I don't look at my unit circle. I would just say, okay, pi over 6 is here because I'm counting by sixths. 1, 6, 2, 6, 3, 6. I don't get very far, right? 1, 6. I would answer long line, short line. Cosine is the x value. So cosine is the long line. What value did I say it had to be if it was the long line? The square root of 3 over 2. So I would answer cosine of pi over 6 is the square root of 3 over 2. Guess what the square root of 3 divided by 2 is? So 0.866. Yeah, it's just our calculator gives us as a decimal. Our calculator will not, and where's my computer program? If you can make a calculator do irrational numbers, our calculator still can't do irrational. So our calculator cannot say the square root of 3 over 2. So it has to give us this decimal. So let's try this one. What is sine of pi over 6? Well, sine of pi over 6, long line, short line. So my sine is the y value. My sine is the y value. So it's 1/2. What will my calculator give me? 0.5. Yeah, so it's not like the calculator is still something else. The calculator is just giving me these x's and y's. It's just most of the time it gives it to us as a decimal, because most of them deal with irrational numbers. Or 3 is irrational. Okay, let's do cosine of 5 pi over 6. Now, it's up to you. You can look at your unit circle. That's not the end of the world. But you kind of want to try to see, because randomly these might just pop up, and you'd have to go find your unit circle and different things. It just comes up once in a while when we're doing calculus. So the question is, can you kind of do it on your own? 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. So I kind of put it where it's at. And then I do long line, short line. Long line, short line. Is cosine the long line or the short line? Cosine goes with x, and x is always first. So x was the long line, so it has to be square root of 3 over 2. And then I went to the left, So it has to be negative. Now you can look on your unit circle, find 5 pi over 6, and you would still have to at least know that cosine is the x coordinate. And we should have wrote, hopefully, negative square root of 3. How about sine of pi over 2? What, am I going to count by sixes or am I going to count by fourths? It doesn't matter, right? You could either do 1, 6, 2, 6, 3 over 6, or if you count by fourths, this would be a little bit higher. This would be 1/4, and this would take you to 2/4. The coordinates of this point I know are 0, 1, whether I look at my unit circle or I should just kind of know it. And sine is the y value. And if you typed in sine of pi over 2, it would give you 1. The calculator would give you 1. Question, how are we doing? Okay, so you can either look at your unit circle or kind of count around and then figure out where you're at. Let's do cosine of 5 pi over 4. So look it up or count around. So this one I'm definitely counting by the fourths. 1/4, 2/4, 3/4, 4/4, 5/4. And I can't go wrong. What does it have to be? The fourths we like. It must be square root of 2 over 2. So now we just have to decide negative or positive. And actually in quadrant 3, they're both negative, right? Technically, I'm taking the x value, but they're both negative. Now, what about something like this? This comes up even less, but let's just do it. Sine of negative pi over 3. And then we'll try to get to just a few of those other ones. We just spent how much time filling out the unit circle? We never wrote down negative pi over 3. Who's teaching this class? All right, so how do we do? Do we remember how we do negatives? Negative angle measures. Instead of going up and around, you go down and around. So this one you're kind of forced to go ahead and count again. So this is negative pi over 6. And then this one is negative 2 pi over 6. But that reduces the pi over 3. But for negative, you go down and around. You kind of have to start over counting anyways. And then, so that's the same as what? We would be looking at positive. We would be looking at 5 pi over 3. We should mark that. We should have marked that off at 10 pi over 6, and then the next one would have been 11. So negative, we're going down. Sine is the y coordinate. So short line, long line. First one's x, second one's y. So negative because I went down, square root of 3 over 2. Sine is, and we could do this. What is cosine of negative pi over 3? Cosine is the x. So it would be 1/2. Short line, long line. All right, how about tangent of 5 pi over 6? Tangent 5 pi over 6. All right, so we count around sixes. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. X is the long line, Y is the short line. X is long, Y is short. Or you could just write it, since we have this picture, we start at 3/2, that's negative, and then 1/2. And then you just have to remember tangent is, does anyone remember what is tangent? Tangent is y over x. Tangent is y over x. So then you just go at it, y is 1/2. X is negative square root of 3/2. Instead of dividing, multiply by the reciprocal. It still is negative, so -2 over square root of 3. The 2's cancel, the negative does not. A lot of times we don't leave it like that. We don't rationalize quite as much anymore. Let's see, I don't know if I wrote down. Yeah, I did rationalize, so, but I'm okay with that. Otherwise, if we rationalize negative square root of 3. How about cotangent of, let's see if I wrote it down. Cotangent of pi over 2. Does anyone remember the pi over 2? 1/6, 2/6, 3/6 is 1/2, or you could do 1/4, 2/4. So this is 0, 1. And then you just think you're on an xy coordinate plane. This point here, just think xy coordinate plane on 0, 1. Cotangent is x over y. X is 0, y is 1. 0 over 1 equals 0. What happens if it was 1 over 0? What's our answer there? We just got done talking about that yesterday, right? 0 on the bottom's a problem. We write down undefined. So let's see if we can even put that. Let's do tangent of pi over 2. Tangent of pi over 2 is y over x. Tangent of pi over 2 is y over x. So that would be 1 over 0, and that is undefined. Extra credit. Now remember we talked about the sine wave and the cosine wave. What's on the graph of tangent at pi over 2? What have undefined? What do we put there? Picture what tangent looks like. Has anyone ever graphed tangent? You see it. And we're going to come up, and we're going to do this, I think, tomorrow. Undefined asymptotes. We're going to talk about asymptotes tomorrow. The graph approaches but never touches. Undefined creates an asymptote on the graph. Okay, let's do this one. Let's do cosecant of 7 pi over 4. Cosecant. Do this one and one more. Cosecant 7 pi over 4. So again, it's okay. We did fill it out, so it's okay if you look at the unit circle, but also kind of try to see if you can do it on your own. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. Puts it right there. It's a fourth. We can't go wrong. It has to be what? Square root of 2 over 2. X is positive. Y is negative. X is positive. Y is negative. Cosecant is 1 over. Cosecant is 1 over. Which one? Y. So cosecant is 1 over y. So 1 over negative square root of 2 over 2. So we flip that. So negative 2 over the square root of 2. This one we probably should rationalize. Let's yeah. When we rationalize, what happens? We get negative 2 square root of 2, but the square root of 2 times the square root of 2 is 2. And that cancels, so negative square root of 2. In higher math, we like to rationalize if we can cancel and simplify. If we can't, then we don't care about rationalizing. But you're not really going to know unless you do it, unless you get really good at it. You can kind of look and kind of do it in your head. So that's the rule of thumb. You rationalize. So this we would definitely want to rationalize. Okay? But you never know until you do it. All right, let's do a secant. A secant 2 pi over 3. Where does that put us? 2 pi over 3, if we change it to 6, would be 4 6. So 1 6, 2 6, 3 6, 4 6. So that might have been a good one to talk about because you had to change it to 6, 4 pi over 6. Short line, long line. So short is 1/2, long square root of 3 over 2. And secant is 1 over x. So 1 over x, which is negative 1/2. And what does that simplify to? Flip it over. We're past. All right, so try those. Try those on your home. The nice thing is you don't have anything right now, but yeah, we're supposed to end at 10:20. Okay, so done. So you've got the worksheet. Try it. You can look at your unit circle, or you can draw. This is considered a picture, guys. I know it's nothing fancy, but that's what I consider. Count around, put your dot, think about where you're at on the unit circle. Okay. All right.